Let us now learn about chemical stoichiometry. The very first question is this: what is the meaning of stoichiometry? It simply means that we want to be able to predict how much of the products we expect in a reaction if we know the amount of the reactants we are beginning with. Or we want to know how much of the reactants we need to prepare a certain amount of the product. To understand stoichiometry very well, it is very easy to connect it to how we prepare foods. So let us take a look at the recipe for preparing pancake. If this is my recipe for preparing pancake, 1 cup of flour plus 2 eggs plus 3 ounces of milk and a lot of all the other ingredients. Let us assume this will give me 5 pancakes. This is a recipe. Now, take a look at a chemical recipe. Nitrogen, which is a gas, when reacted with 3 hydrogen, will give us 2 ammonia. Look at the 2 recipes. You can see some similarities immediately. Both recipes have coefficients. The only difference between these 2 recipes is the interpretation of the coefficients. In the recipe for cooking, we have 1 cup, we have 2 eggs, we have 3 ounces, and we have 5 numbers of pancakes. So, the coefficients have different meanings. However, the coefficients in a balanced chemical equation have only one meaning, and that is that they all represent moles, which means we can interpret this chemical equation as 1 mole of nitrogen gas reacting with 3 moles of hydrogen gas to give 2 moles of ammonia gas. Please remember that. Now, beginning from the recipe for cooking, imagine you have 10 eggs and you have a lot of flour. So you have flour in excess. You have a lot of milk. You have excess of milk. Given only 10 eggs, how many pancakes can you possibly make if you have enough of all the other ingredients? You should be able to quickly estimate this, but let us do it systematically. Since 2 eggs will normally give us 5 pancakes, then if we have 10 eggs, we can use the relationship between the number of eggs and the number of pancakes as a conversion factor. which means we can multiply this by 2 eggs will normally give us 5 pancakes. Eggs will cancel out. 10 times 5 divided by 2 will give us 25 pancakes. Very straightforward. If you know the relationship between what you have and what you want, you can use that relationship as a conversion factor. Let us now apply that same understanding to chemistry. If in a chemical reaction you have excess nitrogen gas, but you only have 2.5 moles of hydrogen gas, and you want to predict how much of ammonia gas, how many moles of ammonia gas can you get? Using the same idea as we did for the pancakes above, we can use the relationship between what we know and what we want as a conversion factor. So 2.5 moles of hydrogen gas was supplied. The relationship between what we want and what we know is that normally 3 moles of hydrogen gas will give us 2 moles of ammonia gas. If you cross out moles of hydrogen gas, then you can multiply 2.5 by 2 and divide by 3. And my calculator says it should be 1.666667 moles of ammonia, which we then can round appropriately as 1.7 moles of ammonia, because the measurement given to us in this question is 2.5 moles, which is 2 significant figures. Let us now take a look at another problem that is similar to what we just did. If 0.026 mole of molecular oxygen, so this molecular oxygen is 0.026 moles, reacts with excess octane. This octane is in excess. According to the reaction below, how many moles of water, so we want to know the moles of water, would be formed? If you look at the reaction, you would see the direct relationship between what you want and what you know. The relationship is that 25 moles of molecular oxygen will normally give us 18 moles of water. So if we have 0.026 moles of molecular oxygen, we can use the relationship between what we want and what we know as our conversion factor, which will be 25 moles of oxygen will normally give 18 moles of water. Moles of oxygen will cancel out. My calculator gives me 0.01872 moles of water, which we then need to round to two significant figures based on the measurement given to us. So this will be 0.019 moles of water. Let us now go back to my pancake recipe. If a friend of mine gives me 2.5 dozen of eggs as a gift, and I want to calculate how much pancakes I can make from that if I have excess of milk and excess of flour in my house, how do I go about predicting how much pancakes? Look at the only difference between what we are doing now and what we have done. The difference is that my eggs are now given in dozen, but my recipe is written in the number of eggs, which means that to complete this calculation, I will first need to convert my eggs from dozen and then use the relationship between what I know and what I want. This is what I'm saying. So if I have 2.5 dozen of eggs, and I know that 1 dozen of egg is equal to 12 eggs, I can simply cancel out the dozen, which means that I have converted to the total number of eggs that I have at the beginning of this cooking exercise. Now I can relate what I know to what I want. I know that the relationship is that normally 2 eggs will give me 5 pancakes. Eggs will cancel out, and then I will use my calculator to finish the rest, which means that I have 75 pancakes that I can produce if I was gifted 2.5 dozen of eggs. What I want you to note about this calculation is that we are beginning with something that has a different unit than the unit in our recipe. Now, let us take a look at a similar question to that. Take a look at this question. How many grams of aluminum oxide will form when 135 grams of aluminum reacts with excess iron 3 oxide according to the reaction below? The very first thing to note here is that my recipe is written in moles, but this question is talking about grams. So I will first need to find a way to change the grams to moles, and then I will be able to relate what I know to what I want, and I'll be able to find my answer. Let us take it one step at a time. We were given 135 grams of aluminum. We want to find the mass of aluminum oxide. So let us map out our strategy. We will first need to convert the mass of aluminum to moles of aluminum, because my recipe is written in moles. And then we will relate aluminum to aluminum oxide to find the moles of aluminum oxide. And then we will convert the moles of aluminum oxide to mass of aluminum oxide. That is how we plan to do this. Let us now solve the problem together. So we have 135 grams of aluminum. We want to change that to moles of aluminum. The relationship between mass and mole is known. We will need a copy of the periodic table. For aluminum, 1 mole of aluminum would have a mass of 26.98. So 1 mole of aluminum will have a mass of 26.98 grams if we just use 2 decimal places from the periodic table. Grams of aluminum will cancel out. We have now converted to the moles of aluminum. Now we move on to the next step, which is to relate what we want to what we know so that we can find what we want. The relationship between the two is that in the balanced equation, normally 2 moles of aluminum will give me 1 mole of aluminum oxide. Moles of aluminum will cancel out. Now that I have known the moles of aluminum oxide, I can now convert the mole of aluminum oxide to the mass. And from the periodic table, I would need oxygen. So I have aluminum oxide, 2 multiplied by 26.98 for aluminum and 3 multiplied by 16.00 to 2 decimal places for oxygen. If you add up everything here, you should get approximately 101.96 gram per mole for aluminum oxide. So the relationship between the mole of aluminum oxide and the grams will be that 1 mole of aluminum oxide will have a mass of 101.96 grams of aluminum oxide, which is essentially saying the molar mass. And the moles of aluminum oxide will cancel out. If you punch all of these numbers into a calculator, you should arrive at 255.0889548 grams of aluminum oxide, which you can then round to 3 significant figures based on the measurement: 255 grams of aluminum oxide. Let us solve another problem that is similar to what we just did. If 28.6 grams of dinitrogen tetrahydride. So we have 28.6 grams of this is used in the reaction below with excess dinitrogen tetroxide, excess of this. How many grams, which means we want to find the mass of molecular nitrogen, can be obtained? So we want to know the mass of this. Again, remember that the coefficients in the balanced chemical equation are in moles. And another thing I want to point out, the equation must be balanced. If the equation is not balanced, it is like having a bad recipe. Let us now plan how we want to go about solving this problem. We will first convert the mass of N2H4 to moles of N2H4. We have to do that so that we would be able to relate what we know to what we want. And then we will use the relationship between what we know and what we want to find the moles of the nitrogen that we want to find based on relationship. And then we will convert the moles of nitrogen to the mass of nitrogen. Let us now do it one step at a time. We were given 28.6 grams of N2H4. To convert it to moles, we would need to look at the periodic table. On the periodic table, nitrogen is essentially 14.01 and hydrogen is essentially 1.01. So N2H4 will give us a molar mass of 32.06 gram per mole. So 32.06 grams of N2H4 is normally equal to 1 mole of N2H4. We know that grams will cancel out. And then we will relate what we want to what we know. The relationship is that normally 2 moles of N2H4 will give us 3 moles of N2. So 3 moles of N2 will be obtained from 2 moles of N2H4. Moles will cancel out. Now we have calculated the moles of N2. All we need to do now is to convert the moles of N2 back to the mass of N2. And using the periodic table, you will find that 1 mole of nitrogen gas will have a mass of 28.02 grams. So moles will cancel. And then we will use the calculator to complete the rest. If you use your calculator, you should get 37.494,011.23 grams of nitrogen gas, which you should then round to 3 significant figures based on the measurement given to you. that will be 37.5 grams of nitrogen. I now want you to pause your video and solve this problem by yourself. Okay, let us now take a look at it together. How many grams of hydrogen chloride, so we want to know mass of hydrogen chloride, are needed to completely react with 30.0 grams of molecular oxygen? This is 30.0 grams according to the reaction below. Again, before you begin anything here, please ensure that you check that the equation is balanced, because if the recipe is not correct, nothing would make sense. This equation is balanced. Now, if we have 30.0 grams of molecular oxygen, we first need to change it to moles. And we know that 1 mole of molecular oxygen will have a mass of 32.00 grams. Grams will cancel out. And then we can relate what we want to what we know. The relationship is that 4 moles of hydrogen chloride will normally combine with 1 mole of O2. So using that relationship, 1 mole of molecular oxygen will normally react with 4 moles of HCl. Moles of oxygen will cancel out. And then we can change the moles of HCl back to the mass of HCl. The relationship, if you check your periodic table, is that 1 mole of HCl will normally give us 36.46 grams of HCl. Moles of HCl will cancel out. And when you punch all of these numbers into your calculator, you should get 136.725 grams of HCl, which, if you round to 3 significant figures based on the measurement given to us, will be 137 grams of HCl.